Jesus Christ! The energies released in this.
Hi, I'm Tyler Fultz. I'm a nuclear engineer, a little over 10 years of experience in the commercial nuclear power industry. From engineering operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Today, we're going to be looking at another one of BlueJay's videos called Radiation in a Nutshell. Wonder if it's as silly as his explanation of worst nuclear failures in history. Let's check it out.
Ah, stupid radiation. Curious, isn't it? What the? Mutant bird! As we've learned from our Fallout games and HBO shows, radiation is quite the fickle beast.
I love this already. Starting off like Fallout, he's even wearing kind of that little vault jumpsuit, if you will. And yeah, I like that he compared Fallout and HBO's Chernobyl series. They're about the same level of realism.
Annoyingly damaging virtual health bars or burning away skin like there's no tomorrow. Say, I bet the question on your mind is how a little bit of spicier can hurt you anyhow.
Spicier.
How can you talk? Have you come for my soul? There, chap, don't you fret. Professor BlueJay is here to answer all your burning radiation questions. Why don't we head on over to my laboratory to fill you in on all there is to know about radiation and take your soul. Gah! Now, to the average Joe, radiation is thought of as a deadly, invisible force that only lurks in isolated places humans avoid, like Chernobyl, Fukushima, or your DMs. So as long as you avoid sites of nuclear disasters, you'll never have to interact with it. Don't be the average Joe, Tim. They're stupid.
There you go. This is already off to a good start, because that's what most people think of when they think of radiation. It's like, it's this nasty thing that's going to kill you, and it's only going to find in weird spots, when it's literally everywhere.
Radiation is actually very common and around you all the time. Put simply, radiation is the transmission of energy in the form of particles or waves through space or material mediums, and they come in many different varieties. So today, we're going to break down the
Not a bad explanation. I mean, yeah, it's purposefully vague, because it really applies to a lot of things more than just decay of radioactive material. It's like visible light is radiation. And yes, your eyes are radiation detectors.
Types of radiation and scientifically rank them from most to least dangerous by placing them on what scientists call a spectral gradation diagram. A TOR. Let's begin with radiation of the wiggly variety.
A tier list,
Check this out.
technobabble.
Looks kind of like a crazy worm, right? Wrong. This is called the electromagnetic spectrum. It shows the range of frequencies and wavelengths of electromagnetic radiation.
I remember, so I actually went to school in the UK for a few years growing up, and I learned the mnemonic for this, not Roy G. Biv, but Richard of York gave battle in vain. Let me know if you had any mnemonics when you learned about the electromagnetic spectrum in school.
A radiation that gets its name from its oscillating electric and magnetic fields. The faster these waves oscillate, the greater the energy they carry. This spectrum ranges from radio waves at the lowest frequency all the way up to pop culture's.
Let's see. Yeah, that's fairly... Oh, it's from Encyclopedia Britannica. Okay, so yeah, it's pretty normal.
Favorite, gamma rays at the highest frequency, which is probably what comes to mind when you think of dangerous radiation. However, most people don't realize that there's actually a much more common type of radiation that is far more dangerous than gamma rays could ever hope to be: visible light. This middle portion of the electromagnetic spectrum, with wavelengths ranging from 380 to 700 nanometers, is the only portion able to be detected by the cone-shaped cells in your eyes.
If you think about all the things that are deadly because of something that you see or a bunch of misinformation out there in certain videos, certain misinformation that might be anti-nuclear, and yeah, visible light can't... I love this. Visible light probably is the most dangerous form of radiation, just based on all of that.
This is great for putting the observe and observable universe. There is the horrid possibility that if just the right combination of wavelengths hit your retinas in just the right way, you could find yourself looking at Twitter. Instead of delivering physical damage to the cellular makeup of your body, this type of radiation decided to spec all the way into the psychological damage skill tree. So much so that victims of visible light often experience symptoms such as nihilism, depression, or the sudden desire to worship Elon Musk at a rate of nearly 100%. Because of this, visible light kicks off our tier list. Spectral gradation diagrammator in the S tier for screw God for cursing us with eyes and forsaking us with a world of horrid.
Sure, why not? It probably is the most dangerous. Yeah, stick it there.
Down here on this end of the spectrum, we have what is called non-ionizing radiation, including the dreadful visible light. And up here where things start to get crazy is what we call ionizing radiation. This type of radiation has sufficient energy to rip individual electrons from the very atoms of your soft, squishy, pathetic body. This process creates ions, hence the name, and can damage your DNA and potentially cause cellular cancer, dysfunction, or death. Meanwhile, non-ionizing radiation pretty much just generates heat and is relatively harmless from a physical perspective. I'm gonna get you all warm and cozy.
I mean, heat does kill you though, but for a significant amount of it to be affected by thermal radiation, you would have died from conduction, just touching something hot, or convection, getting hot air blown into you, way faster than it would be before thermal radiation would get to you, just because the magnitude of heat transfer is so much greater via conduction and convection.
Yeah, you're gonna be all toasty, like it's a sunny day at the beach. Yeah, you're gonna feel like you're on a little vacation, and your grandma's gonna give you a warm pie. It's gonna feel like you had a warm pie for the first time. Yeah, you're gonna feel all warm and safe and sound. God, I'm gonna warm you up so fucking much.
Get a little weird.
Ionizing radiation includes the high-frequency end of the electromagnetic spectrum in all types of nuclear radiation, which we'll get to later, and is typically what people think of when they hear the word radiation. Okay, so I'll just avoid ionizing radiation then. Easy.
Yeah.
Oh, Tim, you sweet, sweet summer child.
Well,
you
Game
might
of
think
Thrones
life
reference.
is all sunshine and rainbows with non-ionizing radiation, but au contraire. While ionizing radiation carries over 1 billion times more energy than their non-ionizing counterparts, that doesn't mean our lower frequency friends don't have a few tricks up their sleeve. Take radio waves, for example. While this radiation has the longest of wavelengths and is the furthest you can get from ionizing radiation, it also allows for mass broadcasted communication over radio devices.
Yep.
This sounds all good and innocent at first, until Cuban guerrillas organize a clandestine revolution of your cozy little suburban town.
I love it more about like misinformation. Yeah, if you think about how many people radio has killed by using spreading misinformation, relaying coordinates to like artillery positions for like in a military operation. So yeah, now granted, I know this is silly. Just like obviously we want radio waves, we want visible light in order to see, but I appreciate this sort of criticism of this, because it does sound kind of like the similar arguments that are anti-nuclear, anti-ionizing radiation, that it's good to bring up these types of radiation that can also be scary in the wrong hands. This is brilliant.
S tier for socialist revolutions. Come on, radio and S tier? That stuff's weak. You ever heard video killed the radio star? I'm glad you brought that up, Tim. Video, whether of the internet or satellite dish variety, is often transmitted through microwaves due to their ability to travel in a tight beam and penetrate Earth's atmosphere to reach the satellites in orbit. While this brings the beauty of my content or JoJo directly to your phone as you sit on the toilet enjoying the pinnacle of leisure, it is also responsible for Wi-Fi, which exposes us to the internet. Dear God. S tier for holy shit, that's a lot of hentai. Infrared.
I think they're all probably going to be S tier, or maybe he's going to rank the ionizing radiation lower just to prove a point. Let's see.
Radiation, while unable to be seen, can be felt in the form of heat. Every object in the universe gives off infrared radiation, with hotter objects emitting more. For example, an iceberg would emit little, but the sun, which makes you feel warm, emits much more. And my YouTube channel, with so much fire content, emits some of the most infrared radiation in the known universe. Right behind Daniel Craig. So while infrared is useful for things like cooking your food, meteorology, and even art preservation, it can also damage your eyes with prolonged exposure, cause mental breakdowns when the remote doesn't work, and makes you quite the easy hunting target for Predator. S tier for shoulder cannons leave no survivors.
There you go, yep, because I was going to say, this one's used in weapons too, so I guess you could argue this is a quote-unquote nuclear weapon using things like lasers and infrared scopes on weapons. This is great.
Ultraviolet radiation is unique because it's mostly non-ionizing, but also marks the beginning of the ionizing portion of the spectrum. It's separated into
That's
UVA,
perfect.
which is long and waltzes through our atmosphere unchallenged, UVB, which is more energetic and has a harder time getting past the border patrol, and UVC, which just really wants to kill you. But it's okay, because the ozone...
I love that on the little border patrol guys, he had the little chemical formulas for ozone in there. That is a super nice and nerdy touch. Really, this is goofy, but it takes talent to make something like radiation good and present it in a goofy, fun way that grabs the attention of the viewer. I love it.
is there to absorb it. You know, granted there's no holes or anything. UV is great in small doses for vitamin D, guiding bees to pollinate flowers, and discovering how gross your hotel room is. But high exposure can lead to serious burns, ulcers, cataracts, cancer, death, and at its worst, make you look like you're from Jersey Shore. S tier for she who sells seashells by the seashore while shunning sunscreen shall slowly succumb to the smoldering sun's sweeping slaughter. Was that necessary? What is life without whimsical alliterations, Tim? Sounds like you're just using fancy wordplay to sound smarter than you actually are. How did this get loose? Now listen up, because we've entered the electron-ripping ionizing territory. X-rays are perhaps most famous for their use in medicine to take a peek at the hard parts of your body. X-rays, like that cute girl at school you have a crush on, pass through many things as if they're semi-transparent. But it's not as if everything is invisible to them. You're just a loser. A material that has a commonly high atomic density, or a CHAD if you will, has no problem stopping X-rays or Stacy in their tracks. This means X-rays...
Never heard anyone say commonly high atomic density. He's just having fun with the acronyms, but it's great.
Scans are able to show your bones because they're densely packed with calcium, an element with a relatively high atomic number, meaning more electrons to absorb X-rays compared to the soft parts of your body. But doctors aren't the only nerds who find X-rays useful, so too do material scientists and engineers. X-ray diffraction is an experimental process that measures the angles and intensities of diffracted X-ray beams shot at a material to determine its crystalline structure. This process has a very wide range of applications, from verifying the integrity of turbine blades in airplanes, to powder analysis, to drug...
Also in nuclear plants too, we use it for turbine tests after an outage.
Identification. Yep, your suspicions were correct, Chase. This shit is definitely mid. While X-rays are relatively safe in the small doses used by doctors and dentists...
Yeah, that's really true. A dental X-ray, you get just as much dose per year from cuddling your spouse than you would from 2 sets of dental X-rays per 6-month dental checkups. So, yeah. Oh yeah, people are radioactive too.
Is nonetheless ionizing, carcinogenic, and has provided superheroes with the means to violate privacy since 1937. S tier for Superman knockoffs are always watching. Gamma rays are the most energetic form of light, and it's not even close. All of the previously discussed forms of electromagnetic radiation can be produced from an electron in an excited state, like this little rascal here. Oh boy, I'm excited! Relaxing to its ground state by releasing a photon, aka light or electromagnetic radiation. Jesus Christ! The energies released in this process are typically around a few electron volts to 100 or many thousands in the case of X-rays. So for perspective, imagine the energy of setting off a little firecracker. Gamma rays, on the other hand, are produced when an extremely high energy photon is emitted from the excited nucleus of an atom that has undergone nuclear decay and is also trying to achieve a ground state.
This is great.
The amount of energy released in this process is tremendous for an atom, in the ballpark of millions of electron volts. So imagine as you're setting off your firecrackers, you accidentally step on an IED. Backed by all that energy, gamma rays are the most penetrating form of radiation out there.
He may mean of just electromagnetic radiation, but neutrons can actually go further.
So much so that it takes a gargantuanly immense garnered allocation of commonly high atomic density material to stop it. Or a gigachad. It requires several inches of lead or a few feet of concrete to stop gamma rays, meaning that pathetic sack of meat you call a body doesn't stand a chance.
Now, one thing I will say is it does just depend on the energy level of gamma rays. Some of them, if they're low, can be stopped by just 1/4 inch of lead. But the bigger ones can go through multiple feet of lead. I think on average, 8 inches is your good for most types of gamma rays, but there is a range, just like there is with anything else.
No matter how much creatine you eat, the ionizing nature of gamma rays means they can kill your cells and cause DNA damage that leads to cancer. Short bursts of high doses can cause acute radiation poisoning, which is so fun that it comes in 4 stages.
That one thing he's shown on the left is an artist's rendition of a gamma ray burst from a black hole. This thing can hit your planet from thousands of light years away, and it's enough radiation to potentially sterilize everything on the planet. It's more energy than is released in the lifetime of the entire solar system, including all the sun's energy over the course of billions of years. And it releases this super quick. In fact, the reason why it doesn't destroy the Earth like the Death Star is just because gamma rays pass through things. They're not imparting that much energy onto the Earth itself, but gamma rays can get pretty crazy in space.
Experience a whole lot of gastrointestinal symptoms like nausea, vomiting, diarrhea, and anorexia. That doesn't sound so bad. I mean, I've been to Taco Bell. Oh, those weren't the stages. Those were all just in the first one, the prodromal stage. But our little gamma ray here is quite the gaslighting girl boss. So next, it attempts to draw you in with a false sense of security in the latent phase, where you start to feel overall improvement and think you actually aren't sick at all. However, just as you begin to feel that rare sensation called happiness, you're then hit with the manifest illness stage. And there's a whole ass table for these symptoms. So just like throw a dart or something.
Yeah, that's a very scary aspect of radiation poisoning, and it's probably one of the most horrific ways to die because you're eventually just bleeding from the inside out, and yeah, it's horrific, and a lot of it depends on how much dose you get. A lot of times you recover. There are various medicines you could take to help with that. But a lot of it is about just flushing the contaminated radioisotopes outside of your body, decreasing the biological half-life, if you will, so your body processes them out more quickly. But you get enough dose, it can be deadly, regardless of what type of treatment and medical attention you get.
But you're not having a fun time. And finally, we have the recovery or death phase. Guess what happens there? Ironically, this pesky cell-killing property is precisely why doctors use gamma rays. While itself a source of cancer, gamma rays can be used in radiotherapy to target cancer cells and destroy them. Kind of like how a sleazy mechanic might break parts of your car before charging to fix them. Due to the nature of how they're produced, gamma rays are our first example of nuclear radiation. All nuclear radiation is ionizing, which is actually why a Geiger counter can be used.
Not all radiation is nuclear. That's one thing that people kind of lump into things. And this is what most people think of. It comes from a radioisotope, an excited atomic nuclei that spits out energy. That's all it is.
Identify the presence of it. A device most recognizable by the characteristic clicking noise it makes. A Geiger counter is simply a metal tube filled with an inert gas and a positively charged rod in the middle. As the radiation enters, it ionizes the gas and sends the ripped off electrons to the charged rod, creating momentary currents that come out as clicks on an attached speaker.
That's actually a really good explanation of how a Geiger counter works. Now, it's a very imprecise form of detector. It's not going to be able to differentiate between, say, alphas, betas, gammas, or even neutrons, because it's just capturing ionizing events. Those are all types of ionizing radiation. Really what we use them for is to check if an area is contaminated, that is to say it has radioisotopes that emit ionizing radiation on the surface. We take a little frisker, we hold it up to it at close range to see if the area is contaminated. Because at this point, we're just looking to see here be radiation or here not be radiation, rather than differentiating between the types of radiation. There are detectors that can do that, but you just need a little bit more sophisticated equipment in order to do so.
Honey, I'm home. George, Daddy.
Oh, that's so cute. Get in here. Oh my God, he made a nuclear family joke. I love it. It's so cute. I want to cuddle a little plushie at him.
Little rascals. How was your day, sweetheart? Mary?
What?
Mary? No!
Oh, Lord.
Wake up! Mary, wake up! Mom? Tommy!
That's
Janie!
so sad.
No! What sick game is this, Lord? No! Huh, a little spicy. Outside of...
Just to detect it. Wow. I feel bad for a little nuclear family.
Gamma rays, alpha, beta, and neutron radiation.
What? Just giving them weapons and stuff. And neutron, because it's neutral, doesn't carry anything. That's hilarious.
make up the 4 types of nuclear radiation. Alpha radiation is when a nucleus ejects an alpha particle, a real heavy boy made up of 2 protons and 2 neutrons. You can think of alpha radiation as the weeb of the radioactive world. They're very big and slow, not able to penetrate paper or the surface of your skin. But with their double positive charge, they're also the most ionizing form of radiation. So if they do manage to get through your defenses, they'll go to town on your cells with their subatomic katana.
Yep, they are 20 times worse than gammas in terms of taking an internal dose, but they won't even penetrate your skin. This is only if you ingest alpha particles. You mentioned radiation therapy earlier. There's actually a form of therapy called brachytherapy, which is short-range, like targeted. So in a zone like the prostate, for treating prostate cancer, you can put an alpha source, just stick it inside the person so it can destroy the cancer cells at close range and then remove it to minimize the overall collateral damage effects of irradiating your entire body just to kill a few cancer cells in the case of an external beam radiotherapy, which is basically like a big X-ray or gamma ray machine.
Beta particles, which are just electrons, are weebs that aren't as far gone as alpha particles, as they still found time to touch grass every once in a while, and therefore are less massive. A bit more in shape, they are the second most ionizing, able to penetrate half an inch of your skin, and are stopped with just a thin plate of metal. Neutron radiation is a
or plastic. They're not going to get through, say, a credit card.
Neutron, and can be thought of as the hippie radiation type. It's unique in that it's kind of chill and doesn't ionize anything directly, able to travel thousands of meters in air only to be stopped by hydrogen-rich materials. But just like how real hippies are pretty harmless themselves, the real danger is how their presence annoys the shit out of everyone around them. So when the neutron is absorbed by a stable atom, it then becomes unstable and leads to the emission of one of the other types of radiation.
Now, that's a bit misleading there, because neutrons can actually be pretty nasty. So I mentioned alphas were 20 times worse than gammas internally. Betas are about twice as bad. They can be comparable to gammas, depending on the energy level. But neutrons can range from 5 to 20 times worse, depending on speed. Average, you can probably scale it to around a 10. Thermal neutrons are around a 5, and so-called fast neutrons are 20. So the hippie analogy, I see where he's going with that, because when certain nuclei absorb these neutrons, then they can become radioactive themselves, and you can even cause fissions, and that's what we use in nuclear reactors to cause fission. But the neutrons themselves, you don't want to be near them. Now, granted, they're only a hazard if you happen to be in an area like an unshielded nuclear reactor, which you're not allowed to have, so the odds of taking too much neutron dose is very low, but it has happened. There have been criticality accidents such as the infamous Demon Core, where people have suffered fatal neutron dose. So I still consider neutrons to be significantly worse than gammas on a per unit basis, but they're less prevalent in areas where people are around.
While nuclear radiation is typically associated with man-made city-melting firecrackers, you can actually find it in nature as well. In fact, even bananas contain a trace amount of a radioactive potassium isotope. Doctor, I don't understand. What's wrong with my husband? Well, Martha, there's no easy way to say this. Your husband seems to be suffering from radiation poisoning due to ingesting a large amount of potassium-40. In layman's terms, you could say that he is going bananas.
You would have to eat many millions of bananas in a short period of time to die from radiation poisoning from bananas. In other words, you're going to stuff yourself to death and be unable to breathe due to having so many bananas rammed down your throat. And you're going to die from that long, long before you die from radiation poisoning from them. But this is a goofy illustration.
Dear God, that wasn't funny. Help him. Hey now, don't be a bad apple. What are you talking about? But nuclear radiation, regardless of its contributions to fruit or superheroes, is also responsible for some of the most horrifying and gross diseases and deaths imaginable. S tier for stay away from Soviet engineering. So, how about it, Tim? Feel like a radiation expert? I mean, yeah.
Oh, that was so silly. This one I actually thought was even better than the obscure applications video. This one was so entertaining. It had so many times of just cracking up, and I could tell it was well researched in order, because it takes a certain amount of skill to make something like radiation accessible to everyone and silly and hilarious. So I really enjoyed watching this video. Thanks again for recommending this channel to me. This has been great. And hey, if you like silly nuclear radiation, but you also support its peaceful use, please join me on my journey to a clean, safe, sustainable, nuclear powered, nuclear energy future by liking, subscribing, and commenting. Thank you very much for watching. I'll see you next time.